Hi everyone, welcome to Etabs 2015 Advanced Tutorials, and in this tutorial we'll be dealing with the torsional irregularity check of a building, which is one of the most essential checks that we have to consider in the case of a high-rise building design. So before going to our topic, I would like to give an overview of our model. This is actually a G+20 building in which the first 3 floors are for commercial purposes and the rest 17 floors are actually for residential purposes, in which each floor height is 3 meter, in which each floor will be having 4 apartments, and in the case of commercial space the floor height will be 4 meter. So now let's go to the analysis part. So here I have already analyzed the model. So the load patterns that I have assigned in this model are the dead, live, masonry, and the earthquake load along the x direction and the earthquake load along the y direction. So in the case of irregularity check, Ex and Ey are the main factors that is determining whether a building is irregular or not. So here the earthquake load along the x direction, I have assigned the maximum seismic zone factors here because my building is in a high seismic zone area. So I have given a similar factors for my earthquake load along the y direction. So if you really want to know more about defined load patterns, you can go to our beginner tutorials and I have explained it very well over there. And now let's go to our topic directly. So here we have to be familiar with two terms. The first one is the drift and the second one is the story drift. So first, we have to find the amount of drift that a building undergoes when the earthquake load acts along both x and y direction. For finding the drift of the building, let's go to the topmost floor, that is the 20th floor. So here, when the building is subjected to an earthquake load Ex that is acting along the x direction, the building will undergo a drift or a displacement in x direction. So here, the drift will be maximum or the displacement will be maximum at the corner points of the building, and here I name the drift that is happening at the corner points as R1 and R2. Similarly, when the earthquake load acts along the y direction, that is Ey, the drift that is being produced or the displacement that is produced at the y direction will be R3 and R4 respectively. To find the drift that is acting along each direction of the building, go to deform shape and select the case. So here first I need to find the drift that is acting along the x direction. So I am selecting Ex and click on apply. So now the building has shifted towards the x-axis. That means a displacement is being shown. So to find the drift or the maximum displacement, just keep the cursor on the section where you want to find the drift. So here you can see the ux value is 177.487. If you need to see a magnified value, just right click on it. So you can see that the drift along R1 is along the x direction is 177.487 mm. So similarly we can find the drift at R2. So here I am right clicking it and here you can see along R2 the drift is 178.183 mm. In similar manner we can find the drift along the y direction. So go to the deform shape and select the Ey again and click on apply. So now our building has drifted towards the y direction. So if you just keep the point over here, that is if you need to find the drift at R4, our value is here we have to consider along the y direction. So our drift is 193.421. Similarly at R3 is 196.304 mm. So here you can see that we have already found the drift that is acting along both x and y direction, that is over here. So according to the caudal provisions, the total drift has to be limited to h by 250 value in the case of earthquake loads. So here h is the height of the building. So in our case, our height of a building up to the 20th story is 66 meter. So in our case, or in the case of our building, the permissible allowable drift is 66 divided by 250, that is 264 mm. So if you can just compare the values of permissible drift with respect to the values that we have got along both directions, that is R1, R2, R3 and R4, we can find that our drift values are way lesser than the permissible drift values. So from this we can come to a conclusion that our structure is safe along both axes in the case of total drift. In Etabs 2015, there is an option in which we can see the graphical representation of maximum displacement with respect to each flow, that is along both x and y direction. So to see the graphical representation, go to Display, select the story response plots. So here under Display type, already the maximum story displacement is being selected. So if you need to select some other options also, you can select it from the drop down, but for time being we are just going with the maximum story displacement. And in the case of case or combo, first let's select the EX. So the EX corresponds to the blue line. So here you can see the maximum displacement with respect to each floor being represented in the form of a graphical line. Now if you need to find the maximum displacement with respect to EY direction, here the EY corresponds to the red color. So you can see the red line that is showing the maximum displacement with respect to each story. And likewise we can also maximize the values. Now let's go to the second part of a tutorial, that is the story drift. The story drift in simple terms can be said as the relative displacement of a story with respect to its adjacent story. So for example, if I need to find the story drift at the 19th floor, I need to find the maximum displacement at the 19th and also at the 18th floor for calculating the story drift at the 19th floor. So for that, let's go to the deform shape again and select the EX. And for this time, let's check the contour option and let's see what happens. And click on OK. So here you can see the entire building is being colored depending upon the displacement. So as the height of the building increases, you can see the coloring is being shown with respect to increase in displacement, which means that the blue color is corresponding to the maximum displacement and shows that the topmost story is undergoing the maximum displacement. So now let's check the 19th floor for finding the maximum displacement. So here along the x direction, I am selecting the bottommost edge. So the drift at the 19th floor along the x-axis is 172.855. And next we need to find the maximum displacement at the 18th floor, that is the below floor. So at the 18th floor, the drift or the displacement is 166.848. So here I have obtained the drift values of 19th and the 18th floor, and I have named it as D1 and D2 respectively. So to find the story drift at the 19th floor, I have to find the difference between the both, that is D1 minus D2. So the story drift at the 19th floor will be 6.01 mm. But in the case of Etabs, Etabs displays the story drift value in a different way because they divide the story drift with respect to floor clear height. So here my 19th floor clear height is 2.88 meter. So I have converted the 2.88 meter into mm here. So the both units are in mm. So the value that Etabs displays as a story drift at the 19th floor will be 0.002. To view the story drift that has been calculated by Etabs, go to Display and select Show Tables, and from the Choose Tables, select the Analysis, and from the results, select the displacement and check on story drift and then click on OK. So from this dialog box, you can see the load case or combo. So here I only need the EX combination. So right click on load case or combo and select EX. So here you can find the drift that is being calculated with respect to each flow. So here in before I have calculated the story drift of 19th flow and I have got a value of 0.002, and that's the same value that Etabs has also been calculated. And similar way, you can also calculate the story drift along the Y direction. So now let's go to the final part of our tutorial, that is the torsional irregularity. So I'm going to explain this topic with respect to two cases, that is case 1 and case 2. So now let's go to the case 1. This is a plan section of a 20th story of our original model. And if you can just look closely, you can just see that I have distributed the columns in every part of this structure in such a way that the lateral stiffness is being distributed in a proportional manner. So when the earthquake load acts along X and the Y direction, due to the proportioned distribution of the lateral stiffness, the drift that is happening at these 2 points, that is R1 and R2, will be almost similar or equal. So there will be only slight variation between the drifts happening at these 2 points. But in the case of case 2, I have changed the size of the columns at this topmost side that you can see in the red color. So size of the red columns are way lesser than the size of the green columns. So what will happen is that when the earthquake load acts along the both axes, the tendency of the building to drift along this direction, that is this side, the R1 will be more. So the drift that is happening in R1 will be more compared to R2. So here we can come to a conclusion that there will be huge variation between R1 and R2 due to the variation of lateral stiffness along at the top and the bottom part of the plan section. According to the Cordell provisions, if the Dmax to Daverage ratio is greater than 1.2, then the building is said to have torsional irregularity. So here, Dmax is the maximum drift of the building. Suppose if we are considering along the X direction, we have to take the maximum drift, whether it is R1 or R2. And Daverage is the average value between the two drifts. And here you can see one more condition also, that if the Dmax to Daverage ratio is greater than 1.4, the building is said to have extreme torsional irregularity. So when we design a building, we should make sure that this ratio stays within the limits, that is below 1.2. So as we have seen before, we have considered two cases, that is case 1 and case 2. And here along both X and Y direction, I have obtained the drift values for both cases. So let's see that whether the both case behaves safely when we consider the Dmax to Daverage ratio. So let's first start with the case 1. So in the case 1, we can find that along both X and Y direction, the Dmax to Daverage ratio is within the limits. So here let's consider the case 2 as second. And here along the Y direction, we can find that the ratio is safe, that is within 1.2. But along the X direction, the Dmax to Daverage ratio is greater than the permissible limit, that is 1.2. So here we have to reconsider the design of a building in the case of case 2. So this comes to the end of our tutorial, and if you have any doubts regarding this topic, I have posted an article regarding this topic from civilknowhow.com. You can just read through it, or else you can post your doubts in the comment section of this video. And the next tutorial we will be discussing about the response spectrum analysis. So make sure that you subscribe to our channel.